If u of x equals square root of x, use a linear approximation to find u of 9.6 using u of 9. Okay. So the general idea here is draw a quick picture. So square root of x looks kind of like this, maybe. Okay. And we're told to find 1, 2, 3, 3, 3, 6, 9. This will be 3. And so we want to find the value of 9.6. I wonder how far I can zoom in. Whoop, zoom. And the idea is we'll use a linear approximation. So I think this thing keeps getting shallower and shallower. Like the graph is concave down. So we'll probably overestimate what it actually is. So the way we'll do this is we'll do a tangent line at 9. And the reason we want to use 9 is because we actually know the square root of 9. It's like a, not obvious, but it's 3. The answer is 3. The square root of 9 is 3. Or is it negative? Well, let's go with 3. Okay. So, linear approximation. So what we're going to do then is going to stay... Alright, tangent line, so we're going to do slope. So f of x equals x to the 1/2. F prime of x equals 1/2 x to the negative 1/2. Because power rule, which is the same as 1/2 times 1 over square root of x. Yep, which I'm good with. So what we're going to do is the value of 9.6 will equal the value of 9 plus 0.6, which is 9 minus 9.6, which I should probably write out. 9.6 minus 9 times 1/2 times 1 over square root of 9. So, a little explanation, backing up a little bit. So we got our point right up here. And what we're doing is, we're saying, all right, let's start at f of 9, which is this point right here. We have a delta x. We have a delta y. And we have our derivative, which is dy dx, which I'm going to write delta y, delta x. And this derivative is based on our point at 9. So this is called the Euler approximation. So what we're doing here is, so we have our f of 9, which is the value of y, and we want to find out how far up we have to go for the delta y. So this right here, that's delta x, because it's our x value of 9.6 minus our value of 9. And then we're multiplying this by our dy dx, which is our derivative at 9. And so if you look at this in terms of more just y and x, so we have our y of 9.6, we have our y at 0.9 plus delta x times dy dx. The delta x's cancel, and we're left with y of 9 plus delta y. And so what that says in terms of our graph up here is we got our y of 9, and then we add in our delta y here, and that will give us about our y of 9.6. Make sense? So we have a point we start with, we find how far delta x we're going, and we multiply it by dy dx, and that'll give us our additional approximate delta y that we add on to our original y of 9 to get our bigger y value, which is y of 9.6. All right, actual math. Whoop, whoop. Y of 9 is square root of 9, which is 3, plus 0.6 times 1 over 2 times 1 over 3. Aha. Which equals 3 plus 6 over 10 times 1 over 6. Cancel, cancel. Equals, nope, move down. Equals 3 plus 1 over 10, which equals 3.1. And so the approximation for this will be 3.1. So looking at this from a Wolfram point of view, let's find the square root of 9.6. And it should be a little bit less than 9.1. 3.1. So we get 3.098. Interesting. So this is the actual value. This is the approximated value. And like we said, it'd be a little bit lower than the actual. So I would try not to memorize the formula for this. I know the way I presented it was kind of throw it out there and a little bit confusing. That's fine. If you can understand the concept of what's going on here and how you're doing this approximation, it'll help you out more than just trying to memorize formulas. Did I have the 1/2? Yep, okay. And so that is how you do a linear approximation. And enter right there, 3.1.